Okay, hey guys, it's Lorenzo. I'm going to continue with the calculus topic. So in the last video I went over a bit integration, and I went over the usual ways of solving integration problems. However, there's two very handy methods to solve some integrals that are difficult to solve with just the by just knowing what sometimes you can't really find a certain thing that you can differentiate to give you the integrand. So sometimes it's a bit difficult to solve an integral, alright? So the first method that is used often is integration by substitution, alright? So I'm going to give you just an example because it's kind of difficult to explain otherwise. So we have the integral of x squared plus 3x to the power 4 times 2x plus 3 dx. When you see this integral, there's no immediate way of really finding the integral immediately. There's you can't just use. There's nothing that I immediately think of which the integrand of which I can differentiate to get the integrand, and that's kind of the issue, right? So what we do is we use a substitution. So basically, there is something that's kind of a pattern in substitution integrals, is that there's usually one kind of term that is the derivative of another one. So here you can see that this one is the derivative of this one, because take the derivative of this, you're going to get that. Alright, and then usually we say, alright, let u equal the one that we took the derivative of, or the one that the derivative of is in the equation. So u is equal to x squared plus 3x. And now if we take the derivative of u, so du dx, is going to be equal to 2x plus 3, which is what we have there. So now this integral kind of simplifies to u to the power of 4 times du dx times dx. Now you can just kind of use algebra to cancel out the dx's, because now we're going to have an integral with respect to u, and that's important because now we can actually integrate it. If it was still with respect to x, it wouldn't give us anything useful. So integrate it, so we're going to get u to the power 4, u to the power 5 over 5 plus c. Now we can just plug in u again, so we're going to have x squared plus 3x to the power 5 over 5. And there we go, we've integrated this seemingly integral that seemed pretty difficult at first, right? So that's one method that's you need pretty perfect conditions for. You need that to get basically the derivative of one of the terms in the equation itself. However, sometimes you can kind of alter the integrand to have that in it, and usually the questions we get on exams already have it anyway. They're just given like that, so then it's easy to use substitution. The other important technique is integration by parts. Integration by parts, it's kind of a result of the product rule with derivatives. I'm not going to really have a proof for it now, but it's really intuitive. And basically what it says is if you have an integral with a u function times a v function, and let's call that v dash, so the derivative of v, and then the derivative of this is going to be equal to u times v minus the integral of the derivative of u times v. So kind of when I see this equation, I see it as, okay, I'm going to have two terms in the equation. One, I'm going to take the integral of both times, because you see here it's a derivative, here see it's without the derivative. So one, I take the integral of both times, and the other one, the first term is just going to be itself, and in the second one we take the derivative of it. And you kind of have to choose u and v according to what's easiest. So I'll give you another example. X cosine x dx. All right, so when I see this, you kind when you see this, you kind of have to see which one do I let u be equal to, and which one do I let v be equal to. All right, so you kind of have to see this integral, this one right here. You want it to be easy because you don't want to get another difficult integral, right? Because it's just going to complicate stuff. So which part of this multiplication, or which of these two would make it easiest to take the derivative of and then have another integral with? So the thing I kind of see is if you have the derivative of x, it's just going to be equal to 1, and 1 is a pretty easy number, right? So now we're going to have, so that's what I'm going to say. I'm going to say u is equal to x and v is equal to cosine x. All right, so u, x. All right, times v, but this is v dashed. So to get v, we're going to have to take the integral. Okay, so that's going to be equal to sine of x, derivative of sine of x, cosine x, minus the integral, okay, the derivative of u. Okay, we said u is x, so this is going to be 1 times v again, which again is just the integral. There we go. All right, so then this is going to be equal to x sine x minus, okay, the integral of sine of x. It's going to be minus cosine x plus c. Or c has to be there. So this is going to give us x sine x plus cosine x plus c. There you go, you solved it. So basically, usually when you have an integral that is a product of two separate functions, you usually use the product or the integration by parts, which it's actually pretty simple. I mean, you just, the only difficult part is just choosing which one is going to be your u and which one is going to be your v dash, or the derivative of v. All right, you kind of have to just plan ahead. You have to look ahead. So before you just say, I'm going to let this be u, this be v, just kind of think, well, what's that going to give us? Because we want to actually solve this, right? So you have to choose, you have to choose something that's going to make it easy to solve. All right, that's it.